Hey, for all of you who want to learn more about what are all the materials for in the science kit, probably I'm not going to get through 100 of them because like I said in my last video, custodian wants to go home and so he's probably going to kick me out pretty soon. But I wanted to start off showing you the thing I failed to demonstrate in the earlier video. So here I have this golf tee, which I'm gonna put in, which is going into every kit, and you can put magnets onto that, and ooh, that fell over. I love it when my experiments work perfectly the first time. If I put a magnet around one way, then they stick together. But then, sorry, I have to put this down for my hand. But then what happens when I turn it around the other way? Oops, didn't turn it around. But then, sorry, maybe it'll finally work this time. But then what happens when I turn the magnet around the other way? Whoa, it's floating. That's crazy. That's a really cool way to learn about how magnets have polarity, which is a really important property of magnets. There they are sticking together. Magnets, another thing that we'll do with magnets is, I think I said this in the original video, we'll just try to stick them to as many things as possible and try and figure out what kind of things do they stick to. Oh, doesn't seem like they stick to plastic very well. What about some of this metal stuff? They are sticking to that metal things. Do they stick, so that might be an interesting property of magnets. Do they stick to all metal things? And the thing about magnets is that they can be kind of frustrating sometimes when they get all of the paper clips. That's fun. That helps me learn about them. Let me get two more. Do they stick to that metal thing? Does stick to that metal thing. What about those cool cans that I was talking about that I need more of? These are made out of metal, aren't they? How come it's not sticking to it? Interesting. Maybe we could do some experiments to figure out why this kind of metal doesn't stick to magnets, but other kinds do. That sounds like fun. Oh, what else can you do with these cans, which I need more of? You can learn about static electricity by rubbing a balloon on your head. Oh, balloons are something we're giving away. By rubbing a balloon on your head and then getting it close to the can. And then imagine what happens. The can rolls away. Whoa, weird. How does that work? That's something that I want to experiment with my kids, with my students. Other things that we're going to be doing, other materials. We're going to be, God, it's really hard to have to hold your camera in one hand and do experiments in the other hand. It makes teaching a little bit difficult. So let me try and lean it up against this. What I've got here is a Christmas light that I cut up, and I spent a really long time stripping the ends of every one of them. I also have this 3-volt battery, which I was only able to purchase thanks to some donations that I got, so I appreciate all of y'all who donated to the cause. And what's cool is that 3-volt batteries have such a low current and voltage that it's basically impossible. It is impossible to get shocked from using just one of them. So we can do things like learn about how electricity works using these batteries. Hey, it turns out that electricity is one of the key things that industrialized society runs off of. But a lot of people don't understand how it works. It's pretty complicated, actually. I'm not sure if I completely understand everything about electricity, but there's no way to get to 11th grade physics and, in my mind, be able to really understand electricity if you haven't made a circuit first. Circuits, understand a little bit about how, it's not working when only one is connected. You need to get both You need to complete your circuit to make that work. How come it doesn't work when I connect it only to one side? Lots of things to learn about. We're also giving them aluminum foil. I'm going to give them another wire so that they can, extend their circuits and figure out how can you extend your circuits. You can use another wire to extend your circuits. Can you use a piece of plastic like this that we're giving them to extend your circuits? Probably not. But we should test it first. What about pennies? That work? Can we make switches just like in real circuits? That sort of thing is, I think, an incredibly helpful tool for learning about electricity, which is something that every student should know. Oh, balloons. We're going to use lots of balloons. Oh, I already talked about one thing we can do with balloons, so I don't need to talk about more things to do with balloons. A big part of what this kit is about is allowing kids to make things and engineer things. So in this bag, we're giving them rubber bands and binder clips. There's a couple of different lessons that we're going to do with those. A lot to do with lots of like forces lessons. It's so interesting how you can learn about potential energy, right? All this stored potential energy that can be released. Also can learn about sound and how sound comes from vibrations with rubber bands. Lots of things. Essential, absolutely essential for students to have. And you can make lots of things with rubber bands too, which is what I was talking about engineering for. We've got things like pipe cleaners, which are also really great for doing things like tying different materials together. We'll make some sundials with the chalk. That'll be fun. We've got Alka-Seltzer to get us a little bit of understanding about what chemical reactions are like. Blah, blah, blah. We've got, I just like these for allowing students to make things with popsicle sticks. Probably a lesson or two I can think of to do with those. We use straws for everything. So many things, uses for straws. We use them to learn about like air density and that kind of thing. There's a couple of lessons involved in blanking on what I use straws for, but we do use them quite a bit. Pipettes for moving liquids from one location to another, plus always a good thing for them to start learning how to do if they want to get into the science world. Something harder for younger kids to do, but definitely by the time you're in 6th grade, you can do it. A lot of the materials over here, the fabrics, etc., are again, engineering. Here is my aluminum foil going in this bag, but we already talked about one of the uses for aluminum foil was to like make circuits. But also, I want students to be able to compare different materials. I kind of already talked about the importance of doing that when we were talking about the magnets. But by being able to feel, how does that feel different from this? And then what properties does this material have that this fabric, this plastic piece, they have different different properties, right? One of them will kind of start to have static electrical effects pretty quickly when I start rubbing it together. This one isn't going to do that. Why is that? This one will warm up pretty fast. What about this makes this such a good insulator and blanket? Not that this other one isn't also. So we have lots of materials for that kind of thing. I talked about the ice cube lesson. That can be lots of these different, this allows the opportunity for our students to after I've shown them all the students, we're gonna do the ice cube lesson with 2 materials that I know are gonna show a dramatic effect. Then they can try that same ice cube melting lesson, the one where you put ice cubes on one material and then on another and see which one melts faster. They could try that on all these different sorts of materials. I've also been ripping out the child-appropriate pictures from National Geographic, or not me, the incredible parents who have been helping, so that we can make collages and like science collages, because every single student, I guess I forgot to put this in my prototype, huh? Every single student is going to be getting a science notebook, so that they can start, keeping track of their experiments and observations. Let me put that into my prototype kit so I don't forget about it. I want, to make students like really kind of feel connected to this. I really like, I've learned from some other teachers that to have students like make collages on the outside to like allow them to make it their own. And I wanted to give them some magazines that are kind of like pictures that are kind of sciencey so that they could do that. Ooh, we've got golf balls over here going in this kit. Golf balls and marbles are useful for learning about forces. This is kind of like, I consider this to be like the Rube Goldberg table, dominoes and marbles and buttons and, so many, I mean, it's true, the rubber bands and that kind of thing, the straws could be used on that, but like, we've got a ton of these sorts of things so that students can, this is a very physical science kind of section of the kit, learning about, what exactly do you need to do to get a ball into motion and to keep it in motion? Because if I roll this, eventually it's going to stop if I don't continue to apply some sort of force. Now, okay, I was worried that it would keep on going because the store might have been slanted. But so we can learn about things like that. We've got some different buoyancy lesson materials, absorption. Ooh, magnifying glasses. Every single student is going to be getting a magnifying glasses because one of the most important things that we can do is practice the skill of observation, and magnifying glasses can be a really great tool for that. Okay, you start learning about light in first grade as the next. That's a next generation science standard. You need a mirror to learn about light, ton of different reasons. You learn about perception as a standard in fourth grade. When you start on microscopy in sixth grade, a mirror is very helpful to understand why is it that objects are upside down and reversed. Wow, I got through quite a bit of that. I don't think I got through all 100 materials, but that was a lot. By the way, part of what's happening and what's getting included with these kits is a digital library that I'm going to be making so that folks like at the Exploratorium, who have worked with in the past, they do this amazing teacher professional development thing. And so you kind of become friends with that group after you do that professional development. They are going to be helping me create this digital library. So what the idea being that, let's say we have some pipe cleaners and some rubber bands, and you want to do an activity with that. Let's say you're a teacher, you've gotten these kits that has been provided to them that has rubber bands and pipe cleaners. There's going to be an activity that you can figure out, with those two materials, we can do these kinds of activities, right? And then if you add in another thing like tape, then here's another activity that you can do. And hopefully, what I'm hoping is that families and parents and kids start feeling empowered to start doing science on their own, and thereby You know, just the learning process becomes something that is more self-motivated and fun and, you know, carries with them for a very long time. So I'm very excited about that. If you want to contribute to that, by the way, if you're a teacher, get in contact with me. It's going to be like an open source library, and it's a pretty essential part of this whole process because you know, like a lot of elementary science teachers, elementary teachers are kind of scared about teaching science for whatever reason. Maybe just because they're, you know, they were a history or an English major. So giving them the tools to successfully implement these kits when they get them is really important. You know, and I want to incorporate math lessons and you know, other subjects into the materials, right? You can use dominoes and marbles and dice, which are going in the kits, I guess. I didn't mention those, for things like math lessons and counting. There's the custodian, so that means I have to end this. He wants to go to bed, as I do. Thank you guys so much, and I appreciate your support. Message me if you have any questions. Okay, bye.